All right, so let's try a couple of problems where we're not gonna have any vens or trees or tables. We're just gonna work those formulas. So it says here, if the probability of A is 44% and the probability of B is 22%, and A and B are independent, what is the probability of A or B? So we got a lot in there, but one of the buzzwords I'm noticing is I've got the independent. So I am told they are independent. These events are independent, which means I can use formula 3 or 4 at will. All right, so that I'm okay with. And then I see also they want an or, okay? So let me write down what I know, and then we'll get to what's being asked of us. So if they are independent, I'm just gonna put this off. I'm gonna make some notes off to the side. I know that the probability of A given B is the same as the probability of A, and I also know the probability of A and B is equal to the probability of A times the probability of B. Right? I get to use those formulas because I was told they were independent. Now this is ultimately asking me for the or, meaning I want to use formula 1. So let's do formula 1. That would be A or B, or the probability of A or B, excuse me, is the probability of A plus the probability of B minus the probability of A and B. All right, so this is the one I'm looking for, which means somehow they gave me this one, this one, this one. We just got to figure out how. All right, so I'll put the equal sign here. They told me the probability of A was 0.44. Right? They just straight up told me the probability of B was 0.22. And then here's where I get stuck, right? So we might say, well, I don't know what the probability of A and B is because they didn't flat out give it to me. They secretly gave it to you though, right? Because they told you these were independent events, you know that the probability of A and B is equal to the probability of A times the probability of B. So what I'm gonna do is I'm gonna take this expression and I'm gonna substitute it in right here, right? So instead of writing probability of A and B, I'm gonna write what it's equal to. So I'm gonna write probability of A times the probability of B. That's what I'm allowed to do in here, okay? So this then simplifies, so I know this is 0.44, this is 0.22, and this is 0.44 times 0.22. Now whatever that number is, that's gonna be my end answer. So let's figure this out. So we're gonna go 0.44 plus 0.22 minus 0.44 times 0.22, and we're looking at about 56%, so 0.5632. All right, and then I can see that answer hanging out in part C. All right. So again, formula only, no Venn, no tree, no table, no counting even. This was just formulas. All right, so let's take a look at example 12. All right. So as I'm moving through this, this is event A occurs with a probability of 1/4 and event B with probability 1/3. If A and B are disjoint, then, okay, so I see this word, disjoint, okay? That is my buzzword here. That's like saying mutually exclusive. So for the formulas I know I'm allowed to use, I know the probability of A and B from formula 5, I know it's equal to 0, right? That we now know, we were told that. And actually, if I know the probability of A and B equals 0, I can rule out A, because that's not true, and I can also rule out D. That's not true, right? Because neither of these two numbers are equal to 0. So A and D are out just based on that. And then if I look at my options in B and C, it looks like they're asking me about the OR again, right? So I gotta calculate that OR formula. So let's try that. Let me erase this a little bit just to box it in up top there. Give myself a little bit more room. Okay, so let's try this. We want the probability of A or B. From formula 1, we know it's the probability of A plus the probability of B minus the probability of A and B. All right, so let's figure out what this is. They told us the probability of A was 1/4. They told me the probability of B was 1/3. And I know the probability of A and B is 0 because I was told this was disjoint. So if I can figure out what this sum is between these two fractions, I'll find my answer. So let's try this. We will do 1/4 plus 1/3. and I see it's this fraction, or this decimal, excuse me, 0.583. Now you can use the math frac button on your calculator and find out it was 7/12. All right. Or you could have added the fractions by hand if you wanted to. But let's say you didn't want to do either. You saw that the answer, so let me clear this out and show you. If we were here, you knew that the decimal was 0.583. So then try each of these fractions on your calculator. Try 7 out of 12 and try 1 out of 12. Right? You'll see that the 7 out of 12 was the one that matched, so B must have been your answer. Okay. All right. So now that we're leaving that, we're heading on into part 6, and part 6 means all of the types of problems are fair game. All right, so we're not saying this is a tree, this is a Venn, this is counting, this is formula, table, all fair game. And this is what you would experience on a midterm, right? I'm not going to specifically tell you what type of problem it is. We want to figure it out as we read this. So I always recommend reading these problems, seeing what you can feel about them, all right? So 3 cards show the numbers 1, 2, and 3, 1 number per card. The cards are shuffled and a card chosen. It is replaced, reshuffled, and another card is chosen. What is the probability that at least one of the cards is odd? Okay, so looking at this, I see this as, this is not a table problem. Okay, this is not a formula only because there's words. There's a little bit of counting to it, all right? But to me, when I read this, this sounds more like a tree because I choose a card, replace it, and then choose a card. So I have these successive events happening that I want to keep track of. All right, Venn diagrams usually have phrases like, so many people do this event, so many people do that event, and then this many do both. And I just don't see any of that wording in here. So this is going to be our tree diagram problem. So let me draw a tree. All right, now this is slightly different in that I have 3 branches for my tree because I had 3 different cards I could select. All right, so I could draw a 1, I could draw a 2, or I could draw a 3. So this is slightly different. Usually we do 2 branches, but this one had 3, same principle, so we're gonna practice it. If I have 3 cards and all things are equal, then there's a 1 out of 3 chance that I will pick any one of those cards. So the likelihood I draw 1, 1 out of 3. The likelihood I draw a 2, 1 out of 3. Likelihood I draw a 3, 1 out of 3. Okay, and all of these add up to 1. They should, because if you're drawing 1 card, you're either going to get a 1 or 2 or a 3. Okay, but it says it's replaced, reshuffled, and another card is chosen. So I'm going to pick a second card, and I still have my same 3 options, right? I'm going to have 3 branches off of this. 1, 2, 3. 3 branches off of this. 1, 2, 3. And then again, 1, 2, 3. And it's going to get a little crowded. So I'm going to make these pretty small. Actually, I'm just going to do them by hand. I think with the ruler, it is just too crowded. So 1, 2, 3. 1, 2, 3. And then 1, 2, 3. So here we go. 1, 2, 3. 1, 2, 3. Woo, this is cramped. 1, 2, 3. Okay. Now, for each of these, right, the probability again is 1/3 through all of them. So I have a bunch of little 1/3s hanging out. Okay. So I've got my tree diagram. Now it says, what is the probability that at least one of the cards is even? So I need at least one even. We've talked about at least. Oh, excuse me, not at least one even, at least one odd, if I read this correctly. At least one odd is like saying greater than or equal to 1 odd card. And if you're picking 2 cards, you have just the 3 options. You could get 0 odds, 1 odd, or 2 odds, right? So I could have 0 odd cards, 1 odd card, or 2 odd cards. And basically, if I want greater than or equal to 1, I want the 1 and 2s, right? I just don't want the zeros. So let's start to think about this, right? If I drew a 1 and then I drew a 1, that's 2 odd cards. I want to include that branch. Yeah. If I drew a 1 and then I drew a 2, that is 1 odd card. I would like to include that branch. If I draw a 1 and then I draw a 3, that is 2 odd cards, and that's something I want to include. Right? If I draw a 2 and then I draw a 1, that is 1 odd card. I would like to include it. If I draw a 2 and I draw a 2, that is 0 odd cards. I do not want to include this branch. If I draw a 2 and then I draw a 3, that's 1 odd card. I would like to include it. 3 and then 1 is 2 odd cards. Great. 3 and then 2, 1 odd card. Great. And then last but not least, we've got 3 and 3, which is 2 odd cards. Great. So you can see I actually want quite a few branches. I want 8 of them. I want top, 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 middle, top, bottom, middle, top, middle, bottom, bottom, top, bottom, middle, bottom, bottom. Okay. So if I want the probability of at least 1 odd card, and it depends on how much you want to actually draw all of this out, because we can. All right. This is like saying the probability of 1 and 3 plus the probability of 1 and, let me go in order, 1 and 1 plus 1 and 2 plus 1 and 3. All right, and then on the 2s I want 2 and 1 plus 2 and 3. Right, and then I would also still like 3 and 1, 3 and 2, 3 and 3. And you don't have to write all of this out. I'm just trying to show you the long drawn out version of this. But for 1 and 1, I'm going to multiply 1/3 times 1/3. For 1 and 2, it is also 1/3 times 1/3. Right? For 1 and 3, it is 1/3 times 1/3. For 2 and 1, it is 1/3 times 1/3. For 2 and 3, it is also 1/3 times 1/3. I mean, every branch has the same probability. And so then down here, we have 1/3 times 1/3, another 1/3 times 1/3, 1/3 times 1/3. There's a lot in here. But here's where I would just take a step back. Instead of writing all this and getting kind of caught up in it, just do 1/3 times 1/3 on your calculator, right? It's the number, or it's the fraction 1/9. Yeah. So probability of 1 and 1, right? It's 1/3 times 1/3, which is 1/9. And all of these branches have a probability of 1/9. There are 9 of them, so that's where it's coming from. And how many of those do you want? 1, 2, 3, 4, 5, 6, 7, 8. So if you just multiply this number by 8, you would find out that if you did this whole shenanigans here, it is just 8/9. Okay? So answer D. And for me personally, again, I like to use the complement rule. I know all of these branches have to total out to 1, so I would just subtract from 1 the 1 branch I didn't want. So I would start with 1, and I would subtract out the 2 and 2 branch, right? 1/3 times 1/3, that gets me to 0.8888, which is 8/9. Okay. Hey, Math 43, I want to take a look at number 13 again, and I want to show you just a different way to do this problem. So in the previous part of this video, I showed you the way that I initially thought to do it. This is how my brain worked. And a couple of years ago, I had a student show me a different technique, and I really liked the way she did it. So I just want to show you that option. So we're still pulling cards, right? We're either going to pull a 1, a 2, or a 3, but instead of breaking the branches like I did, 1, 2, 3, and then 1, 2, 3, 1, 2, 3, 1, 2, 3, what she opted was, hey, just categorize them as even and odd. And I actually think that simplifies the problem a little bit. So let me go through here and show you her tree diagram. And we're going to get to the same answer. We're still going to get to 8/9. So I have even here and odd here. And on the first pull, right, you've got 3 options. And one of those 3 is even. So by complement, 2 out of those 3 is odd. And you're going to pick 2 cards, right? We're going to go through this process twice. So I'm gonna go up here, let's go a little even, odd. Give me a sec, we'll go even, odd. And since we're doing this with replacement, right, we pick the card, we look at it, and then we replace it. That replacement is key. Because we're replacing it, these events are now independent, meaning whatever type of card you pull on the first try doesn't have any effect on the probability of what you'll pull on the second. So there's still 3 cards, so 1 out of 3 of those is even, 2 out of 3 is odd, 1 out of 3 is even, 2 out of 3 is odd, and this again, we want the probability of at least 1 odd card. And let's see what branches we want to include here. So if we look at this, if I go on the top branch, right, we have even, even, second branch, even, odd, odd, even, and then odd, odd. Well, if I want at least 1 odd card, I don't want that branch. I do want this branch, I do want this branch, and I do want this branch. So this is the probability of even and odd, plus the probability of odd and even, right? And then we would have plus the probability, what do we have, odd and odd. I have 3 branches that I want to include. So I want to include this branch, and this branch. And these are disjoint events, right? Because if you're going to pull 2 cards, you have to be on one of these 3 branches. You can't be on both of them at the same time. So since they're disjoint, I'm going to add their probabilities using the addition rule. But because I have an and, I'm going to multiply along the branches. So even and odd is, it looks like we've got 1/3 times 2/3. I'm going to add to it odd and even, so 2/3 times 1/3. Then I'm going to add the other branch, the other disjoint branch, 2/3 times 2/3. Now you can head to your calculator if you want at this point, but I'm just going to do it by hand because I do like fractions. So I have 2/9 plus 2/9 plus 4/9, right? Because when you have fractions, you multiply numerators and multiply denominators. Now when you add fractions, you keep the denominator, as long as it's common, and you add or subtract the numerator, and in this case it's add. So I've got 2 plus 2 plus 4, which is 8, and sure enough, I'm getting to option D. Now keep in mind, you could have used the complement rule here, right? I could have said, what's the probability of at least 1 odd card? And when I say complement, I could have done 1 minus the probability of only even cards. And if I wanted to do 1 minus the probability of only evens, that's 1 minus the probability of an even and an even, right? Which would be 1 minus, oops, did that wrong because I know what the answer should be. This would be 1 minus, and then I would do this branch, 1/3 times 1/3, right? And you can see this is 1 minus 1/9, and that still gets me to 8/9. So either way you can do this, but I just wanted to show you the other option. I really liked that that student broke it into even and odd instead of 1, 2, 3. All right, thanks so much, everyone. Bye.